Hello everyone, welcome to my channel Experience Physics, and the topic for today's discussion is electric current. So electric current, this topic comes under the chapter Current Electricity of Class 12 Physics of NCERT syllabus. And the list of contents for today's class is definition of electric current, how electric current is defined, and how the value is calculated, and different ways of writing the values of electric current, right? Such an important topic and most fundamental topic of electricity, this electric current, right? Let me first start from the definition of electric current. Electric current is defined as simply the flow of electric charge per unit time. So the definition is flow of electric charge per unit time, or simply we can write it as rate of flow of electric charge or charge. Rate of flow of charge, flow of electric charge per unit time, right? The symbol is, it is denoted by the letter I. Mathematically I can write Q by T. Q by T. The charge carriers, how many charge carriers are flowing through a cross section of a wire or conductor. Let me take this conductor through a cross section of wire. How many charge carriers are flowing per unit time? Usually 1 second, right? So per unit time, how many charge carriers are flowing through this conductor, right? So in chapter 1, under the heading electric charges and fields, we have written Q as NE, quantization of charge. How many electrons, number of electrons, and charge per electron. If you multiply both, we will get the value of charge, total amount of charge, right? I can simply write Q is equal to N into E. Be careful, or remember, N I have used the capital letter N, because the small letter N, its meaning is free electron density. So small letter N, it is free electron density. Under the topic drift velocity, we will use this small letter N frequently, right? This is capital letter N, total number of free electrons available in the conductor. So Q is equal to Ne upon T, right? So mathematically we can write, so E, the value of charge is minus 1.6 into 10 to the power minus 19 coulomb. The charge of a single electron is negative charge. To denote it, minus sign we are using E is equal to minus 1.6 into 10 to the power of minus 19 coulomb, right? We can put here, and number of electrons. How many electrons are crossing this cross-sectional area? How many electrons are crossing this cross-sectional area per unit time? This is simply defined as current, right? However, this formula is useful only if the number of electrons are constant. If N is constant, only if N is constant, I can use this formula. If N is continuously varying with respect to time, this formula cannot be used. I have to go for some other means, right? For example, let me take this form of, yes, this is Q and T, it is not constant. The number of electrons are not constant. Q is equal to N into E. If N is equal to constant, I will get a constant line. If N is equal to constant, right? But I am not getting this line. Instead, it is varying this way. Time to time, it is varying. N is varying with respect to time. Time to time, it is varying. In this case, how to calculate the value of current, right? So for this case, two forms of writing the value of current. The first one is average value. We will see how the average value is calculated. Average value is calculated between a time interval, between T1 and T2, a time interval. What is the value of Q present at T1? What is the value of Q present? Present means through the conductor. How many? Number of electrons are flowing through the conductor. How many number of electrons are going through the conductor? This is Q2. This can be written as change in time or delta T. This can be written as change in Q value because we have assumed the Q value is continuously changing with respect to time. At T1, the value is different. At T2, the value is different. So Q is changing. T always it changes, right? Time always it changes. So T1, Q1, T2, Q2, I am writing I average is equal to, instead of Q by T, I am writing delta Q by delta T. So this is average value. I average or average value of current. Because I is equal to Q by T or NE by T, I cannot use the formula here because the N value is changing. So Q is also changing. This formula is not useful for this case unless we are having this type of curve. For this type of curve only this formula can be useful. For this type of curve, this is not useful. Average value between any time interval, between any two times, T1 and T2. What is the time interval you are interested? You calculate the value of Q1 and Q2, put in the formula and get the average value of current, right? So this is first case. Second case, at one particular instant, this is T1 and T2, this is for example Tx. Exactly at one particular instant, I want to know how many electrons are going and what is the value of charge at that particular instant, right? What to do? Assume delta T is shrinked. Delta T is reduced. If it is reduced further and further and further, you will reach this point. Delta T is shrinked. It is reduced to reach this point. At that point, I will get only one time instant. Practically, we cannot achieve delta T is equal to 0 because any time can be split into some split seconds. Any seconds can be split into some split seconds. So I cannot reach 0. Instead, I will have a minimum time interval value. I can approximate it as 0. If I approximate it as 0, I can say it is the instant value or instantaneous value, right? What I am doing, I am making delta T to reach 0, to approach 0, right? So same formula I am writing delta Q by delta T but I am limiting delta T, I am making delta T to reach 0, but maximum value is 0, up to 0. I am limiting the value to reach 0 only. So limiting delta T is equal to 0. So I am reaching this instant. Delta T is reduced, further reduced. So this is delta T. Very, very small value, delta T. So at that particular instant, I will get the instantaneous value. Tx is Qx, instantaneous value, right? So is equal to delta, this is I instant. I instant is equal to, if you limit delta T to approach 0, delta Q by delta T, you will get the instantaneous value, right? So instead of writing this expression, it is easy for me, the alternate way of writing this equation. I instant limit delta T tends to 0, delta Q by delta T, or I instant is equal to dQ by dt. So three formulas we have seen here. I is equal to Q by T if the flow is steady. If the flow is a constant one, I is equal to Q by T, then it is equal to NU by T. Between a time interval, I average is equal to delta Q upon delta T. Second formula. Then I instant is equal to dq by dt. Right, clear? I am using the three formulas only. I am going to use these three formulas to solve some numericals in this video lecture. Right. Then unit of current. So Q by T, unit of Q is coulomb and the unit of time is second. So unit of current is coulomb per second. I is equal to Q by T, the unit is coulomb per second, or popularly ampere is the unit which is used to denote the value of current. Ampere, coulomb per second or ampere, right? Please remember, ampere is one of the 7 fundamental units of SI unit system. Ampere is one of the 7 fundamental. So ampere is popularly used to denote the value of current, right? The symbol is I and the unit is ampere. The formula is Q upon T. To find the average value, delta Q by delta T. To find the instantaneous value, dQ by dt. Simple, right? I whether it is scalar or vector, current, electric current, whether it is a scalar or vector, current is always a scalar unit, a scalar quantity. Current is a scalar quantity. It is a scalar quantity. Current is a scalar quantity. Whether it has a direction? No, it doesn't have a direction. It flows in the way how the wire is kept. If the wire is placed in X direction or I cap direction, the current will flow through the I cap direction. If the wire is kept in J cap direction or Y direction, it will flow in the J cap direction or Y direction. Similarly, any direction. Where, in which direction the wire is kept, like water, how the water flows. The water flows in the way the river is going. It takes the way of the river only, right? Water doesn't have any direction. Similarly, the current will always flow in the direction, the wire, where the wire is kept, right? So you will get it know the detail about the direction of current when you study the moving charges under the topic Bio-Savart's law. So there is a law you will study in moving charges chapter, Bio-Savart's law. In Bio-Savart's law, you will use the quantity IDL. This is known as current element. This is vector. Current is scalar. To make it as a vector, we will take DL. DL is the length of the wire. Wire where in which direction it is kept, right? We will see in detail when we go and discuss the Bio-Savart's law, right? Please remember, current is a scalar. It doesn't have any direction, right? Also, it does not obey. Why it is called a scalar? Because it does not obey the laws of vector algebra. It doesn't obey the laws of vector algebra, right? So arithmetically only the currents can be added. 5 plus 3 is equal to 8 amperes. In which direction it is coming, you don't bother about it. For example, this is 5 amperes and this is 2 amperes. If they are connected at this point, a knot is made here, then there will be 7 amperes flowing through this conductor, third conductor. Conductor 1 carries 5 amperes, conductor 2 carries 7 amperes, and 7 will be the answer which will be flowing through the third conductor, right? In which direction the wire is kept, right? It will not affect the calculation. The current will be flowing in this direction only, but the direction of the current won't affect the calculation, right? So scalar unit, a scalar quantity, it doesn't obey the laws of vectors. So it's a scalar, right? So we will solve some numericals using the three formulas. I is equal to Q by T or NE by T. I is equal to I average. I average is equal to delta Q by delta T. I instantaneous is equal to dQ by dt. These three formulas I am going to use few numericals, right? So from these three formulas, under the chapter, under this topic electric current, these three formulas are enough for us to find any value where the question is asked, right? For any value we can get. For example, Q, charge value. Charge value we can derive from this formula only. Do not remember too many formulas. I will tell you when we go and solve that particular problem, right? If Q is equal to T square plus 4T plus 5, find I instantaneous at T is equal to 3 seconds and I average from T is equal to 0 to 2 seconds. Right? Both instantaneous value and average value have been asked. Q is given T square plus 4T plus 5. I instant at T is equal to 3 seconds. I average between T 0 to 2 seconds. Right. First, I instant we will find. I instant is equal to dq by dt. Instantaneous value delta q by delta t, and make delta t approach to 0. Right, we can write dq by dt. d by dt of q value t square plus 4t plus 5. Differentiating 2t plus 4, it's 0. Right. Put t is equal to 3 seconds here. 2 into 3 plus 4. So 10 amperes. Instantaneous value is 10 amperes. So 10 amperes, 10 amperes. Two options are there. Let us find the average value. I average. I average is equal to delta Q by delta T. That is Q final minus Q initial upon T final minus T initial. Initial time, final time. What is the value of Q at the initial time? What is the value of Q at the final time? Right? Take the ratio. So Q final, initial time is 0, final time is 2 seconds. I average between 0 to 2 seconds. 0 to 2 seconds. Initial time 0. Put 0 here. 0 plus 0. Final is 2 seconds. So 2 square plus 4 into 2 plus 5. 2 square plus 4 into 2, 8 plus 5. This is Q final minus Q initial. T is equal to 0. 0, 0 plus 5 only. And the final second is 2. Initial time is 0. This is 4 plus 8 plus 5, 17 minus 5 upon 2. 12 by 2 is equal to 6 amperes. I average is equal to 6 amperes, right? This is option 1. I instantaneous 10 amperes and I average is equal to 6 amperes, clear? So I am going to the second problem. The current flowing through a wire depends on time as I is equal to 3t square plus 2t plus 5. The charge flowing through the cross section of the wire in time t is equal to 0 to t is equal to 2 seconds. Q is asked. I is given 3t square plus 2t plus 5. Yes. Last problem, Q was given, I was asked. Here I is asked, Q is given. Right. Let me write the same formula. I is equal to dq by dt. Q is here. We have to separate the Q. dq is available now. If you integrate it, you will get Q. So both sides integrate. dq I dt. Then the left hand side I will get Q. This is I dt. Then put I here. So Q is equal to integral of I dt. I is equal to 3t square plus 2t plus 5. So I am not remembering this formula. I have remembered only this formula. I is equal to dq by dt. From this formula you separate it. Enough. Q is equal to integral of 3t square plus 2t plus 5 dt. Limits. The time is between 0 to 2 seconds. So dt, the time is 0 to 2 seconds. Integral of 3t square, 3 constant, t square is t cube by 3. The limits are 0 to 2. Integral of 2t, 2 t square by 2. Limits 0 to 2. 5 constant, I will get t only. The limits 0 to 2. So 3 can be removed. Here 2 can be removed. T cube, put 2 here. 8 cube minus 0. Upper limit 2, 2 cube 8, lower limit 0. Plus upper limit 2, 2 square 4, lower limit 0, 0 square plus upper limit 2, lower limit 0. This is 2 cube. Yes, 2 cube will be 8 plus 4 plus 10. So this is 22. Q is equal to 22 coulomb. The answer is 22 coulomb. Yes, option A. 22 coulomb. I is given, Q is asked. The same formula. From this formula only, I am writing what is the value of Q. A flow of 10 to the power 7 electrons per second in a conducting wire constitutes a current of 10 power 7 electrons are flowing through a conductor. This much of electrons are flowing through the conductor per second. What is the value of current? So ampere, it is 1 coulomb per 1 second. So ampere, all the options are given in ampere each unit. 10 to the power of 7 electrons. So fixed number of electrons are flowing. So the first formula is enough for us. I is equal to Q by T or NU by T. Fixed number 10 to the power 7 electrons. Fixed number of electrons are flowing. So the value is constant. It is not varying. The last two problems, the value Q is varying and the current is varying. Current is given in the form of one equation with respect to time. T square. T was coming. Here it is fixed value, right? So N is equal to 10 to the power of 7 into E value 1.6 into 10 to the power minus 19. The T is equal to 1 second. This is minus 19, this is 10 to the power of 7. So this will be 1.6 into 10 to the power of minus 12 amperes. Yes, option A. 1.6 into 10 to the power of minus 12 amperes. Fixed number of electrons, so this formula is correct. A current of 1 milliampere is flowing through a copper wire. How many electrons will pass a given point in wire per second? The last problem, N was given, 10 to the power of 7 electrons was flowing. What is the value of current? But here current is given. How many electrons? N value is asked. I is given. N is asked. Right. So I is equal to, again the current is constant, so fixed number of electrons we will use. I is equal to Q by T is equal to NE by T. I is equal to NE by T. N is equal to IT by E. I is equal to 1 milliamperes, 1 into 10 to the power minus 3. The time is per second. Time is per second, 1 second. E will be 1.6 into 10 to the power minus 19. So this will be 1 by 1.6. I am working the power only first. 10 to the power minus 19, this will be plus 19, plus 19, 19 minus 3 will be 16. 10 to the power 16. 1 divided by 1.6. This is a famous number. You have to remember this number very often, right? 1 by 1.6 is equal to 0.625. So 1 by 1, reciprocal of 1 by 1.6, right? This is 0.625. You have to remember this value. It will be needed frequently. 10 to the power 16. So the answer is number of electrons. This much of electrons are flowing through the wire to constitute 1 milliamperes. So such a big number, 10 to the power of 16. This much of electrons are needed to create just 1 milliampere. Look at the value. Very, very, very minimum value of current has to be created if the conductor is carrying this much of electrons. N is equal to 0.625 into 10 to the power of 16. It is 6.25. Yes, I can rewrite it as 6.25 into 10 to the power of 15. This will be the answer. Yes, clear? I move into next problem. If the charge flowing through a conductor is given as Q, Q is given T cube minus 60 plus 4 coulomb, then the current is 0. So the Q value is varying with respect to time. It is not a steady flow, constant flow. With respect to time, it is varying. So it is going to become 0 at one particular time. That is the meaning of this question. If the charge flowing through a conductor is given as one equation, then the current is 0 at t is equal to what? At what second the current is going to be 0? Q is written in the form of one equation. Let us write I in terms of time. Q in terms of time is given because we need to make I is equal to 0, right? So Q is given in a form of one time equation. I is equal to dq by dt. d by dt, Q is equal to t cube minus 60 plus 4. If you differentiate it, 3t square minus 6 I. Now I have obtained I in the form of time, 3t square minus 6, right? After differentiating it, I is going to become 0. I is going to become 0 at one particular time. 3t square minus 6. If you equate it, you will get what is the time. 3t square is equal to 6. T square is equal to 2. T is equal to root 2. T is equal to root 2. Yes. Q is given as one time equation. With respect to time, Q is varying. Find I in terms of t. Q in terms of time is given. Find I in terms of t. Then make I is equal to 0. Simple. Idea is important. Simple. I is equal to make I is equal to 0. You will get the time equation. Then equate to. Then find the value of t. Yes. If the current I varies with the time t as I is equal to A minus Bt. Determine the charge flow. Determine the charge flow till the time current becomes 0. Like the previous formula, problem. Till the time current becomes 0. I is equal to A minus Bt. So in the last problem, when the current becomes 0 was asked, right? Here I is equal to A minus Bt, Q is equal to what, right? When I is becoming 0, first step, when I is becoming 0. First, let us find this. I is equal to the time. When I is becoming 0, I is equal to A minus BT. Put I is equal to 0. So, A is equal to BT. T is equal to A minus B. When T is equal to A by B, when T is equal to A by B, the current is going to become 0, right? The question is to find Q. I is equal to dq by dt. As usual, separate Q, integrate it both sides, obtain this equation. I is given A minus BT time 0 to A minus A by B. Q is equal to, instead of I am writing its equation I dt. Instead of I am writing it T 0 to A by B. That is the time. The current is becoming 0 when T is equal to A by B. The current is becoming 0. So 0 to A by B. The final time A by B. At A by B, the current is going to become 0, right? Let us integrate it. A, this will be AT, 0 A by B minus B is constant. This will be T square by 2, 0 A by B. Putting the upper limit A into A by B, the lower limit 0. Instead of T, I am putting the upper limit and the lower limit. A is constant, I am taking outside. Minus B, B by 2 in fact, T square, A square by B square minus 0. This is A square by B minus 0. Then this is B by 2. This is A square by B square. One B we can remove. This is A square 1 by 2. 1 by 2 A square by B. This is A square by B. This is half A square by B. So the answer will be half A square by B. 1 A square by B minus 1 by 2 A square by B. The answer is A square by B. This will be the answer. A square by 2B. Yes, option A. So I is given in the form of time equation. Find when it is becoming 0. Time interval. This put in the integral as time limit. Initial time 0, final time A by B. Because at T is equal to A by B, the current is going to become 0. Yes. Then usual procedure what we have done in the previous problem. Yes. Next problem. A current through a wire depends on time as I is equal to alpha T plus beta T square. Where alpha is equal to 20 ampere, beta is equal to 8 ampere per second square. Find the charge crossed through a section of the wire in 15 seconds. Q crossed 0 to 15 seconds. Alpha and beta values let us put in the I equation. I is equal to alpha T. So this is 20T plus beta T square, 8 T square. Question is Q. I is equal to dq by dt. Separate Q. If you integrate it, you will get this side Q only. Yes. Q is equal to integral of I dt. Q is equal to integral of I dt. I is equal to, now it is 20t plus 8t square. The time is 0 to 15 seconds. Q crossed between 0 to 15. If we integrate it, 20t square by 2, 0 to 15, plus 8 t cube by 3, 0 to 15. So this can be made as 10. 10 into t square, 15 square minus 0, plus by 3 can be taken outside. This is 15 cube. Instead of t, I am writing the upper limit 15 cube minus 0 cube is 0. Yes. This can be written as 10 into 15 square is 225 plus 15 cube, 225 into 15, right? 15 into 15 square. For some convenience, I am splitting 15 cube as 15 into 15 square. So this can be made as 5. 5 into 8, 40. 10 into 225 is 2250, the first term. This is 8 into 5 is 40, 40 into 15 square. 2250 plus 40 into 225. 40 into 225. 450 it is 9,000. This will be 9,000. 2250 plus 9,000. So 11,250. The answer is Q is equal to 11,250 coulomb. Option D. Alpha value, beta values are given. Some constant I is given as one equation. Alpha and beta value are given separately. Right? In a hydrogen atom, the electron makes about 0.6 into 10 power 16 revolutions per second around the nucleus. Around the nucleus, hydrogen atom, one electron. We know in hydrogen atom there is only one electron. The electron is making 0.6 revolutions per second. So this is frequency. Revolutions per second, frequency. In a single second, it is making on 0.6 into 10 to the power of 16. .6 into 10 to the power of 16 revolutions per second around the nucleus. Determine the average current at any point on the orbit of electron. The question is to find the current, right? So it is only one electron, fixed number of electrons. So we will write I is equal to Q by T, that is Ne by T. N is equal to 1 electron, so N is equal to 1. This is E by T. E value we can write, this is 1.6 into 10 to the power of minus 19 by T. T value we have to calculate from the frequency. It is revolutions per second. I want the time for one revolutions. This much of revolutions it is making, right? We know F is equal to 1 by T. T is equal to 1 by F. T is equal to 1 by F. So ulta, 1 by T is 1 by F is equal to T. So 1 by 0.6 into 10 to the power of 16. Revolutions per second will become seconds per revolutions over, right? So T is equal to 1 by F. So this is 1 by F. Instead of T we can write 1 by F then this F will go up. So I is equal to 1.6 into 10 to the power of minus 19. F will go up. F is equal to 0.6. I am writing it straight away. The F will go up. T is equal to 1 by F. I am making T is equal to 1 by F. F value is 0.6 into 10 to the power of 16. So this is 1.6 into 0.6. It is 0.96. 19. This is 16 minus 3. So this is the answer. 0.96 into 10 to the power of minus 3 amperes. 0.96 into 10 to the power milliamperes. Yes. Is equal to 0.96 milliamperes. Option B. Next problem. 10,000 alpha particles per minute are passing through a straight tube of radius r. Its radius is r. 10,000 alpha particles are passing through this tube. The resulting electric current is approximately I is equal to what? This is r value, radius is r, 10,000 alpha particles. So 10,000 alpha particles means it is fixed number of alpha particles flowing. So I is equal to q by t, fixed number of alpha particles are flowing. So you don't need to write dq by dt or delta q by dt. Q by t. N is equal to 10,000. Then E by T. How many electrons the alpha particles are containing? Alpha particle can be viewed as, we know alpha particle can be viewed as nucleus part of helium. Nucleus part of helium. Alpha particle, that is, it has 0 electrons, but it has 2 protons and 2 neutrons. So instead of E, I will write the 2 protons. Charge of proton. Right? The charge of proton and the charge of electron are same. Right? Is equal to 10,000 is N value. One alpha particle. Here instead of E, let me write alpha. One alpha particle has 2 protons. So this is 1.6 into 10 to the power of minus 19. Only thing is it is plus value. For E, it is minus value. Right? So 10,000 alpha by T, 10,000 into, for single alpha, 2 protons, 2 into 1.6. Yes. Divided by T. It is per minute. Per minute. 60. So this can be made as 3. So this is 10,000, 1, 2, 3 zeros minus 19. So this is 1 by 3 into 1.6 into 10 to the power minus 16. So 3 zeros I have removed. 1.6 by 3, approximately the 1.6 can be written as 1.5. So 1.5 by 3 is 0.5 into 10 to the power of minus 16 is the answer. Yes, option A. 0.5 into 10 to the power of minus 16. We can make the approximation because the question itself they are giving you the hint. Approximate answer can be put here. So 1.6 I am writing as approximately 1.5. 1.5 by 3 it is 0.5 amperes. 0.5 into 10 to the power of minus 16 amperes. An electronic charge E revolves in a circular orbit of radius r around a nucleus with speed v. Circular orbit, an electronic charge with speed v V meter per second. The equivalent current is I is equal to what? The question is, so E is given, time in terms of E is given. Time is not given directly, instead it is given as V, velocity, meter per second, right? We have to take or find the time from the V equation. So only one electron, so we will write NE by T is equal to E by T, N is equal to 1. The time I need, it is V is, the unit of V is meter per second. What is the distance? What is the time? So is equal to, the distance is its a circumference. It is revolving around the nucleus, circular orbit around the nucleus. So the circumference is 2 pi r per time t. So V is equal to 2 pi r by t. From here I will make what is t, 2 pi r by V. Put here. T is substituted here. E upon, instead of T, 2 pi r by V. So V is meter per second. Meter is nothing but the unit of the distance. The distance is circumference, 2 pi r. R is given, nucleus, orbit of radius r. So circumference is 2 pi r. The time taken is t second. From here t is equal to 2 pi r V. Put t. What is the value of t in that equation, right? So this is E. V will go up EV by 2 pi r. This is the answer. I is equal to EV by 2 pi r. Yes. Option A. EV by 2 pi r. Right. Next problem I am going. In a hydrogen atom, the electron is moving in a circular path of radius 5.1 into 10 to the power of minus 11 meter. So radius is equal to 5.1 into 10 to the power of minus 11 meter with a speed 1.9 into 10 to the power of 6 meter per second. The equivalent current is, it is similar to the one what we have seen in the previous problem. R radius, V it is given, right? Values are given here. So I is equal to what? Right? So I is equal to E by T. Hydrogen atom, it is having only one electron. So E by T. E 1.6 into 10 to the power of minus 19. The T value I am calculating separately. V is given. V some meter per second. For meter, circumference. For second, time. So T is equal to 2 pi r by T. 2 pi r by V. T is equal to 2 pi r by V. 2 into 3.14 pi into r value 5.1 into 10 to the power of minus 11 divided by V is equal to 1.9 into 10 to the power of 6. This can be taken up 1.6 into 10 to the power of minus 19 into 1.9 into 10 to the power of 6 divided by 2 into 3.14 into 5.1 into 10 to the power of minus 11. 1.6, 3.14, this can be approximate as 1.5. So we will approximate it and find the nearest answer, then we can choose our option. So this can be approximated as 3. 1.6 I am making it as 1.5. 3.1 I am making it as 3.14, I am making it as 3. Yes. Similarly, the 2 and 1.9, if you approximate it, you can remove. So this is 1.5 and this is 3. So 2. Rewriting 10 power minus 19 into 10 power 6. This is removed. 10 power minus 19. This is also removed. 10 power 6. This 2 is removed. This is 2 into 5.1 into 10 to the power of minus 11. This is minus 19 plus 6. So 10 power minus 13. This can be written as 10 approximately. 2 into 5.1 can be written as 10. So this will be 10 power minus 10. This is 10. I am reducing 1 power minus 11. So this is 10 power minus 10. Is equal to 10 power minus 3. If the 10 power minus 10, if it goes up, 10 power minus 3. So this is 1 milliamperes approximately. The answer is approximately 1 milliamperes. Yes. So you can approximate the nearest, because in such a questions you can find the hint as approximate answer, right? So they are asking you to find the approximate answer. So this much of approximation will help us to make the calculation faster. Right? So nearest approximation we have to make 1.6, this is 1.5, 3.14 it is 3. Similarly 5.1 I am making it as 5, 2 into 5, yes, I am writing it as 10. So the answer is approximately 1 milliamperes. An electron is moving in a circular path of radius 5.1. 5.1 into 10 to the power minus 11. An electron is, yes, 10 to the power of, I think there is a typing mistake. 10 to the power of 11 meter means it is a big number. 5.1 into 10 to the power of minus 11 meter at a frequency of 6.8 into 10 to the power of 15 revolutions per second. The equivalent current is approximately equal to, I is equal to what? I is equal to only one electron, so I is equal to E by T. E value 1.6 into 10 to the power of minus 19. T value is 1 by F. F is given. So 1 by 6.8 into 10 to the power 15. This is time value. This will go up. So 1.6 into 6.8 into 10 to the power 15. Again we can make the approximation. Approximately 1.6 you can make it as 1.5. 6.8 you can make it as 7. So this will be 7 into 1.5, 10.5. Times 10 to the power 15. So this is the answer. I is equal to 10.5 into 10 to the power 15. Now 1.6 into 10 to the power minus 19 I have missed. Minus 19 I have missed. sorry, 1.6 into 10 to the power of minus 19 into 6.8 into 10 to the power 15. Yes. So this, as I previously discussed, I am making it as 1.6. This is 7. So this will be 10.5 minus 19 plus 15 minus 4. So all are with minus 3. So this is 1.05 into 10 to the power minus 3 is our answer. 1.05. 1.05 into 10 to the power minus 3. So the nearest answer is 1.1 into 10 to the power minus 3. So this approximation, we can, if we make the accurate value, we will get 1.1 into 10 to the power minus 3. So here the R value is given just to confuse you. The R value is not at all needed. Redundancy, it is not at all needed here, right? I is equal to Q by T or E by T, T is equal to 1 by F, yes, over. R value is not at all required. Just to confuse you, they have given this data. Yes, this is a graphical question. The charge on a capacitor plate in a circuit is a function of time, Q versus T. Q versus T is given, function of time. The value of current at T is equal to 4 seconds. At T is equal to 4 seconds, 0, 2, 4, 6, 8. The Q value is varying in this fashion. It is at T is equal to 4 seconds. Exactly at this instant, what is the value of I? This is in the question. So Q varies here. Instantaneous current they are asking. Exactly at T is equal to 4 seconds means at this particular instant. Instantaneous current they are asking. So this is I is equal to instantaneous value. We will write this formula, I instant. I instant is equal to dq by dt. Here what is the value of dq by dt? Here dq by dt, it is a slope, so change. If there is a slope, there occurs some change. Here there is a slope, so change is taking place. But here it is constant, q value is constant here. If q is equal to 3, differentiation of 3 is equal to 0, no change. So at this instant dq by dt is equal to 0. So I is equal to 0 here. At this instant between 2 and 6, in this interval, the charge is constant. Q is constant, 3 microcoulomb. So I is equal to dq by dt, no change. dq by dt is equal to 0. So naturally I is equal to 0. Option B. So only conceptually you must be strong. So this is also a graphical question. The answers are also given in the form of graphs. Q versus T, the graph of charge Q versus time T in a conductor is given below. The corresponding current I versus T would be 1, 2, 3, 4. 4 options are given. 1, 2, 3, 4. 4 options are given in the form of graphs. We have to find the which option is correct, which graph is correct. Q versus T is given, I versus T is given in the form of answers. Q versus D is in the question. Yes. Like in the previous problem, Q is varying here. 0 to 5 seconds it is varying. 5 to 10 seconds Q is not varying. 10 to 15 seconds it is varying. 15 to 20 seconds it is again varying. It is increasing, then constant, increasing, then decreasing. This is the nature of Q versus T. Which graph is most suitable for this question? Yes. What is the average value? Let us find. the average value in this interval 5 minus 0 in this interval delta q by delta t is equal to final value minus initial value 10 minus 0 final time minus initial time. So q final is 10, initial q is 0. So this is delta q is equal to 10 minus 0. Delta t is 5 minus 0, 2. So in this region, the current value will be 2 amperes. In this region, q is constant. Like in the previous problem, if q doesn't change, the current will be 0, dq by dt. Or we can find 10 minus 10 is equal to, if you write delta q, 10 final charge is 10, initial charge is also 10, 10 minus 10 is equal to 0. So here current value is 0 amperes. So this 0 to 5, 2 amperes, 5 to 10, 0 amperes. Using these two values, we can find the nearest one. 2 amperes. This is constant. At every instant, 2 current value. This is current is increasing. Again the current is increasing. The current is 2 amperes. Yes. Next the current is 0 amperes. Yes. Answer 2. Option 2 is the answer. Here the current is 0. Yes. This is also wrong. Current is 2 ampere between 0 to 5. Q final minus Q initial. T final minus T initial. Average value. So final is 10, initial is 0. 10 minus 0 by 5 minus 0. The answer is 2 ampere. Here there is no change. 0 ampere. For this case also we can find. Here the final Q final is 20. The Q initial is 10. For this slope I am writing. The final time is 15. The initial time is 10. So this is 10 by 5 is equal to 2. Here also I am getting 2 ampere. Yes. Between 10 to 15, the current is 15. Yes. This is also matching. Right. For this slope also we can find. Final Q is 0. Initial Q is 20. So this is 0 minus 20 delta Q by delta T I am writing. For the last case, final is 0, initial is 20, 20 minus 15. So this is minus 20 by 5, minus 4, minus 4, yes. Minus 4. This is also matched. So for this slope, final minus initial, final minus initial, final minus initial, final minus initial. Right. So this one, current I where is again graphical question. Current I where versus time. Graph through a conductor is shown in the figure. I versus time T graph. Yes. Average current through the conductor in the interval 0 to 15 second. 0 to 15 second. Average current. I average is asked. Average is asked. So I average is equal to, what is the formula? Delta Q upon delta T, that is Q final minus Q initial upon T final minus T initial. But the graph is not Q versus T. It is I versus T. So we have to find the Q value here. What is Q? Let us say it is in this triangle Q1 and in this triangle Q2. What is Q? This is one triangle. What is Q value? Or otherwise, Between 0 to 5 seconds, what is the Q value? Between 5 to 15 seconds, what is the Q value we have to find? So I is equal to dq by dt. dq is equal to I into dt. If you integrate both sides, Q is equal to I dt. This means area under the IT curve. Integral means finding the area, right? This area will be Q. This is the area under IT curve. IT curve, this is Q. Area under IT curve is Q. So in this area Q1 and in this area it is Q2. Area under IT curve is Q. So if we find the area, that is the meaning of integral IDT. Integral of IDT means area under the curve. So this is Q1 and this is Q2. Two areas I have to find. Q1 is equal to this area. It's on triangle of into the base is 5, the height is 10. So this will be 50 by 2 is 25. Q1, this area is 25. And Q2 of base 15 minus 5. 15 minus 5, 10. And the height is 10. So this is 100 by 2, it is 50. So total area between 0 to 15, yes, between the interval 0 to 15, the total area Q1 plus Q2. Total area is Q1 plus Q2. 50 plus 25, 75. So I average is equal to Q by T. So separately we have found, yes. So this formula is not used here. Separately we have calculated by integrating the equation in the graph. By finding the area we have obtained. So total Q is 75. Total time is 15. So the answer is 5. I average is equal to 5 amperes. Yes, the last option. Yes. So we have solved some numericals. I have used only the three relations. I is equal to NE by T. Q by T. From the definition we wrote Q by T. From the quantization of charge we are writing it as NE by T. Then the average value I average delta Q by delta T. Then I instant dq by dt. If I is given in the form of time, right, whether differentiation is needed or integration needed, you find it which one is needed. Accordingly you do the problem, right. So it is enough for you to remember nearly 15 problems we have solved here, to remember only these three formulas, right. So let us again meet in the next topic, drift velocity. We will again meet. The drift velocity is one of the important topics under the chapter current electricity. This is the most fundamental topic, drift velocity. So in this lecture, we have defined what is the current and how the values are calculated only. How current is produced, in what velocity it is moving. So these inner details we can be known after studying the drift velocity, such an important topic. From this topic only a lot of formulas, the Ohm's law, etc., everything, the formula for resistance, everything will be derived, right. So let us meet in the next class for the topic drift velocity. Thank you all.